Sound is okay now.
Okay.
It was muted. You can use this now too. This is one mic.
Where are all the students? The physical ones. Okay, they are more online, right?
There are more students online, of course.
The C class are 11. Most of them attend
They prefer it.
they are female.
So I don't need the mic, right? So I can just talk. Okay.
Are we ready for the class?
Yes, we are. Sorry.
Just bring yourself. Attention for the class. The class is starting.
Our class is starting. Good morning.
Good morning.
Good morning. Good morning. You're all welcome. I will have to apologize for the slight delay, but you didn't really miss much. I can see you people were busy with some. Was that assignment?
Yes.
Okay, you're trying to from the last class, the last AI class. Wow, that's good. All right, so this is a follow-up from the last class, and I think so far you people are conversant with the fundamentals and the basics of artificial intelligence.
Yes.
You're not answering.
I hope so.
You don't know.
I hope so.
You hope so.
Please communicate. Yes and no.
Okay. So, hello, are you with us? Please, can you come forward so that we can all be together? So we are going further, but we'll just go through some kind of, will I say, preambles before we go deeper. Because if you look clearly, it says introduction to deep learning. And we'll just go through what you have done before. I want to know at what stage that most of you are in just now. And then we'll go further, we'll go deeper into artificial intelligence. Very interesting technology, yeah. AI is the boss of the now. And you people are going to be the expert at the end of the day. I like that, the champions. All right, so I am from the Collaborative Center for Artificial Intelligence. We just kind of, we have one here at Cosmopolitan University. And so what we do is what I'm doing now. And we actually, thank you. And we actually collaborate with a lot of people, with students, with industry, with government. We also collaborate with lecturers and students. Again, I will say students. So I hope those of us that are watching online will hear the name. It's the Collaborative Center for Artificial Intelligence, Cosmopolitan University. Try and be one of our members. One of the things we do there is to, accept members for now. So when we meet our quota, before you become a member, you have to pay to be a member. So just go through that. You guys are computer gurus. Just go through the website.
Okay.
Then you go to the website. Just keep following the link, and then it will tell you CCAI. And then you follow that link, and then at the bottom there is a membership icon. Click on it and fill the form. And then I will accept you.
That's the school website, right?
Yes, the school website. Yes. So we will accept you to be a member. And nothing much, but you have first-hand information of all of our activities, our programs, our trainings, and things like that. That will come on. Okay.
It's called Collaborative Center.
Yes, CCAI. Let me go back. That's yours sincerely, and then you see, it's the Collaborative Center for Artificial Intelligence. So please, those of you that are online, try to link with us and be part of us. All right. So I will start by asking us, what is AI? And that question, I'm going to ask it from the perspective of the branches. Because in this part of the world, there's something we have come to realize. They just equate AI to robots. And so we want to clarify that. So we look at the different branches. AI is the umbrella, but it has different branches. And this course is about a major branch of artificial intelligence. And so if I should ask, let's talk. I always like my classes to be very interactive. I learn from you, you learn from me, and then we are all on the same page. So what are the different branches of AI? Who can name just one?
Machine learning.
Machine learning.
Deep learning.
Sorry? Deep learning.
Neural network.
Okay, I'll take that for now. I'll come to that. Yeah.
Machine learning.
Machine learning. That's what. Yes, please add.
Natural language.
Yeah, NLP.
How about business intelligence?
No, that's we can apply it into business intelligence and different kind of yes. But the last one, which is not very popular, is fuzzy logic. How many of us fuzzy logic? Yes, FUZZY logic. This is not happening, right? It's not happening. Y, fuzzy logic. So these are the different branches of AI. Is the streaming still on?
It's off now.
And so most of us, we kind of overlook that. You see, we have mentioned robotics. Did anybody mention robotics?
No.
Yes, it's a major aspect. Okay, now you are saying yes. So you were paying attention in your last class. You look at robotics. You look at
Data science.
these are, they're five. Let me just say it right now. So let me just go on. So that's mention five major branches. We mentioned deep learning. She mentioned neural networks. But the truth of the matter is that deep learning has to do with neural networks. So when you are talking deep learning, you're actually talking neural networks. So some people will say that branch is neural networks, but some people will say deep learning. They are not, I won't say they are the same thing, but deep learning is about neural networks. And so in the course of this, course, we are going to be seeing a lot of neural networks. We're going to be discussing about neural networks, but we need to have our foundation. How did we get here? How did we move from machine learning into deep learning? And so we'll go that way. And so we'll just go over it again. Robotics, machine learning, deep learning, NLP. Now, I like to say NLP, fuzzy logic. And then these are the five major branches. And we go, step by step as we get along. But before the end of this course, you probably will learn more about these other branches of artificial intelligence, especially when we get to the part of the application of all that you have learned. And but the branch we are going to be focusing on just now is asking for the code. The branch that we're going to be focusing right now is deep learning. All right. How did we get to machine learning? We are going to be, the online people are not open. So let me just pause a bit so that we can be on the same page before I start getting a lot of text.
I'd love to know more about you, like your background.
Okay, why off camera?
Yes.
All right. I'm not that private. This is me.
Yeah.
Collaborative center. My background. Okay. My background is computer science, but my research is on intelligent user interfaces, artificial intelligence, and psychology to produce intelligent user interfaces, and it's majorly focused on education. So if you check me out, you can Google me, you will see that I am an artificial intelligence in education specialist. So that's my background. I specialized. First of all, I started with computing science. I started with computing science, just studying about computing science, my first degree, all my trainings and all that. And then because of my interest in academia and education, I had to narrow it down to artificial intelligence in education. And so that is what my research is about. So any of my papers you see online, any of my research you see online, you will notice that it's geared towards AI in education. You want to know my age?
But that's an interesting one.
Oh, really? Guess. Guess.
No, I mean your background.
Okay, the interesting background. Okay, I thought you said the age is an interesting one. No, it's not.
But you look young.
36. So,
We don't have background in computer science
yeah.
because we are struggling.
So really, that's one of the reasons why I asked.
What my background is.
Yeah.
How would you advise?
So I should have just not said that one.
No,
I'm on your track.
from the look of
Oh, you
On
are?
your track.
Okay.
from the look of it, it's like people who have background in computer science are more.
Inclined,
So we that don't have background in computer science, that's
struggling to get there.
grasp
To
what
grasp
is there.
it.
What do we do?
Okay, no, I think you are, I will say, to be very honest, you actually need some level of knowledge, something like a prerequisite before you can understand the dynamics of artificial intelligence. You need it. I don't know if those that are virtual can hear this. You actually need a kind of, that is why you're having introduction to this, introduction to this. In fact, I know that. I know what you are going through. That is why I tailored this teaching to capture these learning objectives. So we understand that at the center, we understand because AI is multidisciplinary. It doesn't have to, first of all, be from the computer science background. In fact, OpenAI boss, the boasts that you don't really need to know how to program. And you can do AI there. You understand? It's multidisciplinary. It is a technology that is cutting across every field. But if you want to go in depth into maybe like designing an AI tool, you just have, that's why you're here, right? You have to go through those basics. There's what you call first principles. You have to understand those first principles, and then you can use it if you want to go deeper. Like if it's just to use the application, you're good. You're good. If you go through, by the time we get to the third module, you'll see that you are very balanced. So no worries. Yeah, okay. Okay, yeah, I'll be right, of course. So now, I just like I told you, I have to tailor it through this way because I do not want to assume that everybody is a computer code. I don't want to assume that. And so we have to start. We're going to learn how we're going to describe the differences between machine learning and conventional programming. And what do we mean by conventional programming?
That's traditional way of coding.
Correct. The traditional way of coding. This is what we all know. This is what, in fact, those people, how many of you have used Scratch? You have used Scratch.
Yes.
You see the way you want to do something, and then you just use the traditional method. You expect a particular result and you get that. So we're going to see the differences, and that's majorly what we're going to do. We're going to tackle 1 and 2 on an understanding of deep neural network design and basic neural network models. So these two, we're going to deal with that today. The next week, we'll take the next one and we'll follow suit till we get to the end. So for the sake of those that are virtual learners, we have to have an understanding of deep neural network design and basic neural network models. This, forget about the neural network design or this computer grammar is technology. It's normal. There's no big deal to it. And then we will be able to demonstrate an understanding. And that's the one I like. I specifically captured that, a demonstration of an understanding of the advanced use of neural networks and to understand the application of deep learning in a wide range of applications, especially in computer vision. And then next, we are going to demonstrate the practical use of computer vision using deep learning, evaluate strengths, weaknesses of the different models, and with optimization, and then demonstrate and understand the use of deep learning in real-world applications. So you can see that we are kind of loaded here, and just stay with us. We'll get there. So, like I said, for many of us that do not have a background in, coding, I know how many of you code well? How many of you are good programmers? What do you use? You use Python.
Python.
Okay. A relative told me that they are learning to do, there's this new programming language, React. Who knows how to use React? Good. You know that you use React. Sorry?
Not that way.
But you know about React. And then there are so many object-oriented programming. Daily news. So many object-oriented programming languages that you can use. But we do not throw away our knowledge of the conventional programming style. We don't. And so that's why I'm bringing this example for your understanding. Now take a look at this scenario. A programmer wants to develop a software to immediately pop out the reminder icon when the computer is turned on. You want to develop that, so that immediately you log onto your system, there is this reminder that is telling you, oh, check your heart rate. Check. What do you like to check first thing in the morning? Your BP.
Yes.
Okay, check my BP. So I can know whether I'm okay or I've gone overboard. And so what is the conventional way of doing that? Can you explain?
Okay, that's
It's captured, you can use the board.
the logic behind the
No,
program.
the conventional way of doing that.
You need to write the code, the steps it involves to get it done.
What are those steps called? Yes?
An alarm.
Okay, you set an alarm.
It's a conventional way of.
Okay. Sorry, I'm in the context of coding.
Okay.
But that's true. You set an alarm. You set an alarm that, okay, this alarm. But what if when the alarm goes off, and then you're thinking, that's frozen cake. You want to be specific. Most of us, when you do a lot of this kind of traditional programming, there are specifications. You want to be specific. That's why we are, trying to write maybe like a set of codes. What are those set of codes called? I mean, set of those steps. There's this word you use. You said something just now.
That's like a logical.
You have to go through a logical process,
yes.
step by step. You are the one that put those steps, and those who translate them into codes using programming languages to get there, right?
Yes.
What are they called? You are developing what?
The program.
There's a word I need. You are developing an algorithm.
Okay.
Yes, you are developing an algorithm. You all know what an algorithm is, don't you? And so And what are we getting from that? The first step is to develop the code, which is you design an algorithm that will help you design the code. And in this case, I have to highlight this input that you feed into the system, right? Okay. And then stick with me. That's why I had to highlight these other ones. There's where we are going. Next, this leads naturally when you run the code, you debug, do everything, all the necessaries. What do you get? Your output. And your output is what? That's beautiful. You can design it any way you like. Some of us are very good with CSS. You just, front end people. My professor used to call it prettify it. You just prettify it, make it beautiful, and eye appeal is good. And what are you getting? You are getting your program, and you do that. And what you are expecting is what you are expecting. It's what you told the system to do, and it's giving you that. And then that is your output. Traditional method, beautiful, fine, easy, predictable, no qualms. You are okay. And we've been doing that for years and years and years. And then there was a disruption in the process. It has been there. Don't think machine learning development just started. It has been there for, in fact, if you check in your last course, did you people do a little bit of the history? 1950, 57 started coming up. From 1940 something, it has been there. But you can now hear about it with the advent of OpenAI. You can now see what it's doing. When I did my research years ago, I was like, when we started going into artificial intelligence, we were doing something wonderful. We came up with an algorithm that was cool, actually. But it's nothing compared to what we have today. And I'm going to revisit it. We are still going to revisit it and put it out there and enjoy the upgrade of what is happening now, which is so mind-blowing. And so, in this case of machine learning development, a programmer learns to develop a software to predict which students will come to school late. Did you see the way they are thinking now? Before, you will write a program, step by step. Okay, now this student will come by this time. This student should come by this time. But in this particular scenario, you don't know. You don't know. And you want somebody to do it. If we go the manual way, maybe the number of staff that you have in the school, this is a school scenario now, the number of staff we have in the school will be so much, they will all stand and line up. And then they check in, you came late. You came late at so time. You are most likely, so they will check and then they will bring the whole group together. Definitely there will be errors and there will be overlaps in the input data and so many intricacies. And at the end of the day, you don't have a perfect system. Okay? But now, the machine can do that for you. The algorithm that you are writing in today's world is different. You just write an algorithm that will make the machine understand the information you give to it. And then it tells you. And then what we are saying, we are not just ending here. That's why I said, let us start from the basis. Let's start coming up. The rest of us, are you understanding what we're saying? Sorry, I'm a base teacher. Not just like, I'm a teacher. So don't worry, I'll go down to the first principles. There's no stupid question. Bring it on and we'll explain it. And so by the time we start writing on the application, you have an understanding of where we are coming from. Are we okay?
Yes.
Okay. So the first step will be to identify the students. How do you identify the students from your last class? How do you identify the students? And by the time you're having when you are saying identify the students, that's just one aspect of it. You are not just identifying the students, you are identifying the time they come in. And then you identify it over time. I thought I wrote it there. Okay, then look at their history. You are looking at the history of how they come, when they come, those that are absent, how often they come, how often they come late. Are you seeing something? There's a pattern coming in here. And what is that pattern? What are you gathering?
Data.
You are gathering data. And you know that AI feeds on what?
Data.
AI feeds on data. And if you give it small data, small results. And so you are careful the kind of data. And the data has to be plenty. Every data about all the students. Because you are trying to tell it, use this to give me an accurate result of what should be. You are the one that have written codes for it to do that. And so when we say machine learning from the last class, you know that it's learning. It's learning from your data, the patterns. It's beginning to learn from everything you are giving it. And then you tell it, identify all the students and their attendance record. Look at their history. If they have come late or not. And then the machine learning is then used to produce a model that predicts which student could potentially be late. You can see that the machine, your algorithm is powering the machine to think intelligently. So you're not the one doing the thinking anymore. The machine is doing the thinking. But you know that we are still the ones behind the scene. We are the one feeding it with the data. So if the data you are feeding it is not sufficient, just like one of my students once said, you give it a snack and you want it to run marathon, give him swallow now. Just feed it with solid, authentic data. So when you put your prompt and say, do this, where's our prompt? Come on, we are together. Where's the prompt?
That predicts.
Beautiful.
Predicts which students.
Produce a model that predicts which students could potentially be late. So when you put it, it will give you, because you have given it enough to be able to give you back that. So do we now understand the former conventional method and this machine learning development method? Stick with me. You can see that the algorithm we have is able, the algorithm already is able to do things and predict on its own. These are the algorithms we call intelligent algorithms. They have become intelligent. You know, that's the fear that one day, we are so excited. You know, you just imagine an algorithm doing this. You know, when I was cooking up this analogy, I was just like, what if we now feed this thing that is so cold, so machine, and you know the characteristics of a machine. They don't feel, they don't have empathy, they don't have emotion, and then you tell it to not do something. You get that? Yes. So that's where we are going. I'm taking you gradually to the deep learning part. We are trying to leave the is it off? Okay. Continue with it. Sorry. So are we seeing the beauty of this technology? I want to show you the difference. You can see the beauty of it, but most importantly, are we seeing the power? We are seeing the power. Towards the end of this course, We are going to tell you when it is in 10 years. We are going to tell you about code. You have to have some kind of cognitive control. So that you don't give too much time to the machine. That's where cognitive analytics will come in. But do you have an understanding of how this system can become? Yes. Good. So let's proceed. So in a nutshell, we have input, we have rules, and we have output. So that's what we want to if we can get that from you. You see input, rules, output. Are we seeing something else there? Input, output, rules. So the machine is now giving you the rules. You told it, do this. And then you said, no problem, I'll do it. Give me the tools to use. After using those tools, it's now giving you the rules of how it's supposed to be. That is what we're talking about. Do you now understand machine learning? Of course. Good. So, and I'll just run through this so that we can all be on the same page. You say, manually built by, there's a lot of human intervention in traditional programming, predefines an output of the program, outline a set of specific rules and functions, and then yields specific results. In fact, I would have added there expected results. So you know what it's going to tell you because this is what you told it to do, and it's doing exactly that. Specific, predictive, expected results, and that is your output. Let's look at the next one. It says the ability of a computer programming to learn and adapt to data without human intervention. The first one has human intervention. So that when I come to you and ask you, please, can you just design a table for me and say the similarities and differences, we are good, right? Okay. And so the use of built-in programs and algorithms to process high quantities of data that provide reliable predictions, and then identify patterns with current information. And so what does that tell us? They now set the rules for you. They tell you this is it. They give you recommendations that is kind of reliable. Just like somebody would just, what perfume do you use? Yeah.
I don't use perfume.
What deodorant do you use? None. What soap do you like?
I use Palmer's.
Palmer's. Nice. Taste. Palmer's. Cocoa butter or what? Which one? Expensive. Nice. I like Palmer's, the original. And you just go on the website and then you search for Palmer's. You probably want to just know the price online before you go to the shop, or you want to buy it online. There is that machine learning algorithm that they have put there. And then don't you wonder, subsequently, when you go, they just begin to recommend different cocoa butter to you. They have extracted information. And then the machine is now the one doing it. Sometimes it can be so annoying. Hello, I know it's crazy now. Just let me browse what I want to browse. And then you are seeing other things. That is what the machine does. It begins to predict. You are the one that told it to do it. Because why did I say you are the one that told it to do it? Before you complain too much. You know we are so lazy to read T's and C's. Do you realize that? Lazy to read T's and C's.
Yes, terms and conditions.
They are hidden terms and conditions. You said it's okay. And so, it's so lengthy for a reason. Very lengthy. And then you're like, click yes, and let's go. And then they start popping up all manner. And that brings about this particular point, making live predictions. And it's identifying patterns, your pattern, what you like to buy within the current information that is available. Our virtual learners, I hope they are getting the basics of this. So in a nutshell, we have seen the two. So let's go a little bit further. Now, this so-called, if you look at machine learning, you see the inputs, and then you see the output, giving you rules. Please put that at the back of your mind. I probably would have put it side by side. Look at it there. If you look at the training data, you have your inputs, you have your desired output in quotes, and then rules. You know what a function is in programming. And then you are looking at rules. We are trying to learn, you're trying to know, most appropriately, you're trying to know about this. And then there's a predicted output, just like we saw in the last slide. And of course, in some of the research work we do, this is usually feedback. We call it the feedback. But I won't use the word feedback because it's called loss function. So let me just describe what we mean by loss function. Now, my marker and my board. Is there a marker? What the flip chat or anything? No, sorry. So just stay with me. And so you have your training data. So when you have, sorry, no, it's okay. I can manage. I can describe it. You have your training data. And so when you have your training data, and then we are looking at the loss function now. What do we mean by loss function in deep learning? Learning must take place. Sorry. Tune your mind to machines. The machine must learn. When we say learning must take place, it's not about you now. It's about the machine. The machine will learn from your training data. That's the data that, just like the first example, the data of the students, the history, how we come and all that, they are learning. That is the training data. And so while that data is fed into the system, and then you are looking at the function that we are trying to learn, it gets a kind of smooth curve. While it is processing, using that algorithm, what is happening? Learning is taking place. It's taking in, the data, it's learning from the data. It's learning from the data. So learning is taking place. And so by the time the predicted output, you check it, and then it is on point, your loss function is most likely, how many of you have a mathematics background here? It's most likely to tend to what? 0. Good. It will tend to 0, which means the learning have taken place. It has predicted the latecomers accurately. That is what we call the loss function. By the time the loss function value is high, something is wrong there. The system, the machine have not properly learned. So what do? You go back and feed it with more data, or you tweak your data. Imagine giving it a data about teachers coming early and late. Is that what it's supposed to learn? It will learn it. It's a machine. It cannot separate like you and me. It will learn it. And then it's giving you what you don't expect. And then by the time it gives you an output of the personnel that is most likely to come late, you are seeing the name of a teacher. And so your loss function value goes high. And so you have to go back and visit that training. And so you have to go back and check your input and the training data into the system again. Now, there's the training data and there's the test data. In the last class, when you talked about training data and test data, what is the test data? Who can just... Okay, please.
It's like after training the model, then a random data, then you want to use the test data to make sure the model can like a random data can maybe give the require expected result with that
Predicted.
random data. So that's the test.
Use the text data.
Yeah.
What's the difference? Yeah.
The test will be a portion, just a little out of the whole lot you have, to see just a trial to see what the outcome will look like before you load.
Yes, before you now finish the, close the program. The model is now working right. What's the difference between the test data and the training data? What's the major difference? No, you. The test data and what? The test data and yeah.
Like test data is data that is used to evaluate the performance of the model and big data.
Good. You are putting it in good context. That was nice. Yeah. What's the difference? What should not happen between the test data and the training data?
The results should not be different. It should give us the same results. If they are, if if the model is working fine, it should give us the exact same results. If not, it should not.
It says that there should not be the training data.
Beautiful. That's what I was looking for.
Okay.
I said, what should not happen?
Okay.
What you said now is good. It should, but please, this is machine. I like that. It should give you what you expected, right? What a good prediction, but that you say exactly the same. It should be close enough, and it should be tending towards a zero loss function. Yeah.
So that's if it is higher, there's a problem.
There's a problem if it is. There's a problem. So you see, that's good class. Well done. And so we understand what we're trying to say right now. Okay. So we can proceed.
What you just said now is different between the test data and the training data is they shouldn't be together.
They should be different, yeah. They should be different. They shouldn't be the same, and they shouldn't be together. You understand? And that's, if not, you have a kind of biased, you learned about bias. You kind of biased predicted output, which you do not want. And then at the end of the day, you're not having a model that can help you.
Based on what I know, when you have a data, just data frame, okay, there's this part that says
data frame, or is it a data set?
A data set, rather. So there's this part that says split into train and tested. So I'm thinking it's still one data set that you try to get into two.
Sharing into two, it depends. Because you know what a data set is, it can be large. And there are some that you kept. It's just like, have you ever, let us use cooking for the benefit of many of us that are not into computing. Let me use this, okay? Let the teacher in me come out now. All right, you are cooking, right? And then there's you cooking. You take from the pot, from the whole lot, and then you take I don't think you are trying to learn. Okay, let me know that you're trying to learn how to cook. Or let's say you're trying to learn to drive. And then your father bought a Rolls. And then there is a Volkswagen Polo in the garage. Which one will he give you to learn? You see what I'm trying to say about the test data and then the training data you're testing. So, you know. Do you understand now? You know what I'm trying to say. Okay, thank you. So let's proceed. Before we are getting to a point where we are going to explain the intelligence in the algorithms of deep learning. But before we get there, have you gone through this? Supervised learning, unsupervised learning, reinforcement learning. Yes. And so you see the different algorithms. One is supervised. I will say that it's almost as if we are doing the traditional method here. You're actually giving it, you understand? There's a way you are so involved in the process that almost predictable what the output will be. And then the unsupervised, I like that. It says the model learns for itself how to categorize and predict data with no pre-existing knowledge. And next we have reinforced learning. That is the part that is really pointing into deep learning. It says the model learns to react to its environment on its own. You see where the power is coming? It's just graduating from one. It started with, because supervised learning, we are getting into unsupervised learning. We're getting into unsupervised learning, and then we're getting to reinforced learning. You can see that the data is beginning to do data analysis. It's beginning to analyze. And then by the time you see how it does that analysis, now you're talking about it. That's what this course is about. So, behold. Do you like my diagram? I tried. But just get what I'm trying to say. Deep learning, it refers to the application of many functions, one after another. In the input, remember I highlighted input. And then the next one, it says the depth provides immense power to the overall function in terms of what it can represent. And what are we trying to say? If you look at this brain, now, at the beginning, when we were looking at the different branches of AI, you mentioned deep learning and you mentioned neural networks. And I said deep learning is about neural networks. And what are you seeing now? Brain. When you hear neural, what comes into your mind? The brain, the human brain. The whole idea of neural networks comes from the concept of the human brain, how the brain functions. I hope you know that there are tens of billions, not millions. There are tens of billions of neurons in this your brain. So when you are not doing a lot of things, you are like, you're wasting this thing. There's so much potential, so much potential. That is why you know that a little child can learn how many languages? No, that's child's play. No. You have your system. When a child, before the child gets to, you can set it up right now if you want to check. Before the child gets to age 12, or 12 is good. Before the child gets to age 10 or 8, the brain of that child has the capacity to learn a kind of a number that even me, I was like, oh, I don't have the exact number. It's on mine. I'm like, wow. So that's why have you noticed that most when we met military personnel that they transfer to different places and their children are still young, their children are non-linguists. When you go to a particular education, you learn the language in that education when you interact with it. And so like that. So your brain, neurons, tens of billions of neurons. I'm trying to give you a foundation for deep learning. When we talk about neural networks, we are talking about the brain, the human brain. That is where that concept of neural network comes in. So you know everything about artificial intelligence, we are borrowing from the natural, and then we are applying it to machines. And so you see, we are looking at this concept of neurons, different neurons connected in a massive network to bring just one output. For you to be able to, what's your name? Stephen. For you to be able to say, my name is Stephen, do you know how many neurons in your brain are connected? And then you bring out that fact. So you see the power of speech recognition. When we talk about natural language processing. You see how beautiful this is. And so when we talk about neural networks, we are now going away from just machine learning, supervised learning, you tell it what to do and all that. We are going deeper. You see that this inner lobe that is capturing the brain part, the inner caucus of the brain. Let me just give you the diagram and then I'll make it. Bring out all your phones. And then let's get busy with our hands. Now, all right. Sir, set up nucleus. Nucleus. See it there. See it on the board. Nucleus. Okay, let me go here. Set up nucleus. Set up endoplasmic reticulum. I'm not a medical doctor. I'm an academic one. Set up dendrite. Set up, oh no. This one. Axion hillock. Set it up. And then set up telodendron. Did I pronounce it well? Then you have the code there, right? Set up synaptic terminals. By the way, did I say anybody should set up the nucleus? You, right? You?
Yes, good question.
Nucleus. Okay, yes, I said you should set up the nucleus. That is the core of the neuron. With this, we are going to see another diagram that tells you how neural network works and how it is formed in the context of deep learning. Okay? So, who's the first person? Or but anyone, when you are ready, just put your hand up and tell us what you have seen there. I like AI.
Okay.
Google is like AI.
Nucleus is
AI is Google.
AI has actually
Yeah.
it has more information.
the nucleus.
No, that's it. We are Nigerian, so okay.
Nucleus.
Okay, wait. Nucleus should be last.
So the Golgi apparatus, also known as the Golgi complex or Golgi body, is an essential organelle in eukaryotic cells. It plays a critical role in the modification, sorting, and packaging of proteins and lipids that are synthesized in the endoplasmic reticulum. Structure of the Golgi. The Golgi apparatus.
So if you got it in definition, that's fine. That's fine. You see the function. What did you say? Which one? Which one is it? Which one? What's the name of what you said?
Golgi apparatus.
Okay, this one. Did you see the role it's playing just there? This is just one neuron. This is just neuron. And the function is it. Apart from the intents that you are getting, it gives you an understanding of how complex just that is doing. That was what I told you. For you to say, my name is Stephen. So many things have gone on there. But, we just move around like, what is happening? Next, you can say on. Who's ready?
I'm ready.
Okay.
Endoplasmic reticulum.
Where is it? Okay, yes. Here.
Yes, it's the largest organelle in the cell and it is a major site of protein synthesis and transport. Protein, protein, lipid, and steroid synthesis.
Good. Next.
Exon yellow.
Yes, that's this one.
Yes.
You see what this is doing?
Says that it's a crucial part of the neuron anatomy, playing a key role.
Please come again. Say it again.
It is a crucial part of a neural anatomy, playing a key role in the integration and transmission of neural signals. Functions are action potential initiation, signal amplification, and signal integration.
Transmission. Axion, that's a special one. But then these axions, they carry all these signals, they are transmitting it. So that you will now know what the output will be at the end of the day. Next, which one is yours? Okay. Yes. Yeah. Who did I give dendrite? You. Okay, good. When after your own is it?
The branch end of nerve cells that come functional connection with other nerve cells.
Okay, that's
Functional connection
connection. Yes, I like that.
with other cells.
With other cells. You see what that function is doing? It looks small, right? And this is just a neuron we're talking about. You can see what's going on there. All right. Now, you.
Dangerous collective messages from the body and the other neurons. They are structured neurons which conduct.
Oh, sorry. Let me say that. Sorry. Come again.
Dendrite. The collected messages from other neurons and other part of the body. And they conducted electrical impulses.
Okay. Oh, that's fine.
So what is first?
You see the way it's collecting from other neurons. It's like it's kind of coordinating. And then there are different special, you see, they said dendritic branches and so forth and so forth. And finally, let's all just take this one, the nucleus.
Nucleus, the central and most important part of an object, or a movement or group, forming the basis for its activity and growth.
Thank you. Now, when we said the different branches of AI, we are talking about going deeper, deep learning. Do you know what the deep is in deep learning? Who can guess? What's the deep in deep learning? Something like that. But let's leave biological stuff and go into digital stuff now. What's the deep in deep learning? Who knows the deep? When they say deep learning is actually, sorry, can I use this? Is machine learning on steroids? Is machine learning a higher form of machine learning? That's why we started by understanding what machine learning is all about. But this we'll say more machine learning.
The advanced,
Has
right?
more
So
power.
the advanced,
The deeper aspect.
Looks like advanced reinforced learning.
Something like that. But there's something I want you to get before we leave. What's the deep in deep learning? I will explain that. But before I explain that, let's interact with our online students. Haja, please, do we have any questions from our virtual learners? Can she hear me? Can she hear me? Do we have any questions from our virtual learners? Haja? Oh, she just went up. Oh, okay. Okay. So, are we okay so far?
yes.
All right. Do you know what the deep in deep learning is? Okay. What did I say about machine learning? Now, if you look at machine learning, you gave it some functions, right?
Yes.
And with those functions, you were the ones that actually wrote the algorithm. And this algorithm is a set of functions that you give to the machine, that's you give the power to the machine to work on your data. Now, this is deep. Let us take what we have all been saying as
But sorry, what's an algorithm?
beautiful. I'm going to explain that. That's from first place. Do I explain it like a programmer? Or should I explain it
I
like
wouldn't understand.
no? What is your discipline? Beautiful. My daughter is studying economics. I love economists. I'm biased. All right. So you see,
Oh, someone said they didn't get the example you gave about train data and test data.
okay. All right. Can you just type it? I will reply to you. This thing because we're going to go way back if I have to do that.
Okay.
I've proceeded. I'm sorry. Any question? How many? Oh God, let me not finish. How many questions?
Looking at the example you gave about trade data and test data.
That's what I just read.
No questions. Only that question.
Yes.
Okay, fine, we can address it at the end of the class, right?
Okay.
We can just play around with it the way we know we are now rules. We can just play around with it and then we need to answer. That's kind of consigning. Why am I not having a lot of questions?
They said we can hear you loud and clear. We understand the prerequisite height you mentioned.
Oh, that's what they said.
Yes.
Thank you very much. That's a good one. You know, for us, if the students are not asking questions or they are asking so many questions, it's saying something. You understand? So that they know it very well or they don't understand it. So, algorithms. We are talking about algorithms. Now we want to estimate algorithms for you. I heard something about scarce resources. Economics, right? And then I think there was a time you told me about macroeconomics. Or what is the mathematics in economics? Is it econometrics? Yes. You said something about. Can you just give me a nutshell about an application in econometrics? You want to listen. You need financial intelligence. You better listen to her.
Well, it's just like a compilation of things.
No, say the one in your field. Just say any, maybe like concept or something that you are comfortable with, that you have worked with before.
Like metrics has to do with gathering of statistical data. That's using different models.
Okay, gathering statistical data. Yeah, that's what I come up with that. Okay, now you're gathering statistical data. And then you now want to use, you want to design a program. Right now, say program. Stop. Okay, yes, you want to design a program that will gather statistical data for a particular function. What do you do? Let us go traditional. What you do is you tell it how you want the data to be gathered. You tell it the kind of data you want it to gather. You tell it when you want that data to be presented. And you tell it where to apply that data. The least, there's a way you tell it, and then you put rules. This is how it's supposed to be. This is what it's supposed to be. This is when you have to come out. You know, we are going to. You see that list of steps that you have just given it is structured and is definite. You didn't change it up and you know it. That's it. Well, the right thing to do. So, in this context, that kind of algorithm, how you want it to be, the step-by-step process of how you want the function to be carried out is an algorithm. In the traditional way, please don't just the traditional English for your understanding. We are kind of doing that. Share, we are entering into digital technology. This is digital. Right? And so you that's what you that's it. All right. Okay, again, all right. Can they hear me?
Yes.
Okay, so while we are waiting for the lights to come on, let's answer our friend, virtually. Said did not understand training data and test data. Who can just drop, Mr. Blue? Can you just give a nutshell of what we talked about, training and test? Yeah.
Okay. For the training and test, we talked about the training data is the data we give to the machine to learn. That's the data it learns from. While the test data is
The test data, yes, thank you very much. Is he correct? Is he correct? The training data.
Yeah.
Beautiful, that was a good one. Where is my guy? He was there. There's a way he put it, the context in which he said it. I want him to say it again for our virtual learning. Okay, written. Talk about the testing data. I hope our virtual learner is speaking this. They are quite correct.
The test data is like the experimental data
it's not part of the training data, but it's like similar.
Yeah.
It has similar variables.
Yeah.
So it's like what we use to ascertain if the model can function according like to the algorithm
Algorithm,
that
yeah.
we want it to, like the output that we want.
Yeah.
So I just see it as like an experimental
Data set, yeah.
data set.
Yeah. Thank you so much. I hope we've answered the question. Are we good? Okay. So let's just hold on a bit. Do you people have questions? So far, what we've been doing so far. This introduction is good. So I will bring further.
So if they can hear me online, I can just explain this. Okay, then when the light comes on, I'll show you the diagram that I extracted from the research. Yes.
I just want to ascertain that I think you said that already, but I just want to ask again that when we were talking earlier about the types of machine learning, we mentioned supervised.
That's the machine learning algorithms. Algorithms.
Yeah. So when we were talking about machine learning.
Yes, what we're talking about with supervised, those are machine learning algorithms.
Okay.
Different types.
Okay, so
Yes.
we talked about supervised,
Yes, unsupervised.
and reinforced.
Yes.
Then you said something about supervised, the reinforced being the machine being able to interact with environments. And you said, okay, with deep learning, it's now an advanced version of that. So I just wanted to confirm if we can say it's an advanced version of reinforced. As deep learning is the advanced version of reinforced learning.
Oh, no, I wouldn't define it
That way.
that way.
Okay.
But what I was trying to say is that when we get to the stage of reinforced learning, deep learning thrives in that environment.
Okay.
And there's a reason why. That's why I'm trying to explain to you the deep in deep learning. Why it can thrive. You can't say you are doing deep learning if it is you are using supervised algorithm. You know, it's not deep learning if you are using supervised algorithm. So, but in the environment of reinforced algorithm, that's reinforced environment. Deep learning thrives there. That's what is, let me say, is a concept that supports deep learning approach when it comes to artificial intelligence. Do I have answered?
Yes, more than an autopilot. So,
when you
since it learns from the environment.
it's now, let's say, when you say auto, there's something about auto that just says zero human intervention. There's zero human intervention, but we know that we were the ones that fed it with data. So I wouldn't use, we have to be careful about our terminologies. So that
Semi-autonomous.
like something towards that area. Let's be yes.
I was trying to make sense of the algorithm, like the three of them. So I kind of
There are minimum 3, there are others.
okay, I kind of view AI now as like it's still traditional. Sorry, with my thoughts, because like there's still a set of rules for it to work, like that algorithm. So like if we feed it any type of data, there is a particular algorithm it has to use to like give it back of any type of data, right? That model in particular. So that's I understand it now, right?
Okay, yeah, when you say like traditional, now if you talk about machine learning, the issue of algorithm comes in, right? But it's a different kind. If you talk of traditional or conventional programming methodologies or method, the issue of algorithm also comes in. But one is different from the other. That's why I won't agree with you that AI is the traditional method. I'll say that because in the traditional method, you know what to expect. There are no predictions. They are definites. You know what to expect. You design what to expect. And if it doesn't, it's not like that, you go back to your code and tweak it. It's not. You say the code is not functional. But in artificial intelligence, you really do not know. Yes, you have written an algorithm for it to do the work, but it will now independently do. Okay, now let's go back to the example I gave. Will you know the students that will most likely come in? You won't know. But in the traditional method, you will know. Because you told it that this is how it's supposed to be. This student is doing like this. You know what I mean?
Yes.
But you don't know. It's because you don't know that makes AI this powerful today and a tool to help us. So you see, there is an upgrade of the traditional method. Yeah.
All right. So, like the scenario you give now about is students coming late or not?
Yes.
I would say probably you might know, but not to a large extent.
No, you cannot be sure.
Okay. Why? Yeah, you can't be sure. Why I said so is, if, for example, like, he came late today. Sorry for using that as an example. If he comes early next week, then he comes late again. If you are being asked to decide if he's going to come late, if you have the chance of coming late, your answer would likely be yes, because out of 5 classes, he came late 3 times.
Okay.
Yeah, so I think based on that, you could decide. But if there are more than one student, maybe a lot, you might not be able to. So I think in that case, you can say AI, it will handle more, it can handle more data for us and do more of everything. Because as an individual, if I have data about, okay, this person coming late or not, it's just one person, I could predict, I might be wrong. That's where the reliability of AI came in when we were discussing.
The answer is a question. I was going there. The second part of what he was saying, the answer is a question. What do you need AI for when we are just 4?
Yeah.
You will know. If you have a classmate of 5, you don't need to tell me who is going with. There is this, you know, when we're in secondary school, there's this, it's a perpetualist. You don't need AI for that. Do you need AI for that? No. But by the time you're talking of thousands of students in a very large school that have senior secondary, junior secondary, and pre, IJMP and whatnot, you need AI. Can you predict?
No.
You answer the question. Are you people on the same page? You understand what he's trying to say? He's correct. That, you know, you believe that yes, you can do it yourself if the data set is not large.
Yes.
But when we are talking, have you, in your last class, did you learn about LLM?
And large language
models.
No.
Large language models. We'll talk about that. I'll check it in. And then we'll talk about large language models. And then you begin to understand what we're talking about here. Right, AI is a very useful tool. In this age, no limitations.
Yeah, the last time we were talking about deep learning, and we said
What is the deep in the deep learning?
yes, but for that, you said something about deep learning thrives in the area of reinforcement. So I want to clarify that. Can we say deep learning, you know, it can do well with reinforcement learning in that area, but it has other stuff that it could do? I mean, can I say it that way?
Stuff. What do you mean by stuff?
Okay, like other function you could perform. That's deep learning now.
Okay, maybe I can answer that for you.
Okay.
I understand where it's going to, and I understand where the misunderstanding is coming from,
Okay.
because we have not gotten to that part.
Okay.
So I'll tell you, the answer to that question is very clear. When we understand it,
Indeed, deep learning. All right.
now we talk about, I don't like this sentence, but can we just go on?
Yes.
Can you hear me?
Yes, they can.
All right. The deep in deep learning. Now, we talked about machine learning. I don't do red lights like that.
Okay.
I'm sorry, you can put it up. Let me just see. When we talked about machine learning, we said there are functions that the machine will have to execute right?
Yes.
And these functions, you design it for it to execute functions. And then that is where we look at those functions led us to the different kinds of algorithms. You can supervise one, unsupervised one, and then
Reinforce.
reinforce. And now we started talking about neural network. And in that, you was entered biology, where you started explaining the role that each component of a neuron, a neutron, will play to be able to bring just one output. How will you do that? Why? You will say that this component is working, this component is working, this component is working, that component is working, and they are all coming together to the nucleus.
Yes.
And then the nucleus coordinates everything. And then Stephen can say my name is Stephen. Right?
Yes.
In a kind of, it's not as complex as the human brain. But neural networks is artificial neural network that is working on that. We got the concept from the human brain, the way it works like that. That's where the concept came from. And then you now have the D is the different layers of functions. And then you put the other layer of function. You put the other layer of function. You put another layer of function. You're going deeper. That's the deep in deep learning. And so all these different functions, it's not just one anymore. Machine learning or just a couple. No. Multiples, different layers, different layers, and they are all coordinated to bring out one output. That's the deep. Maybe in the next class I'll give you the mathematical formula for that. But you can see how just a normal AI now becomes complex AI. Did you pick that question you're trying to ask?
Yes.
About the kind of functions it can perform.
Yes.
It's not just an ordinary thing. We're not playing here.
Yes.
This is machine learning on steroids. Okay.
First one is, what is the difference between traditional programming and deep learning?
Traditional programming and deep learning. That's what we were trying to discuss just now. When you said we taught, traditional, it is not black and white. It's not. I don't know. Can you hear me? Okay, it's not like front and back. They are not opposites, because the way you answer that question is as if one is the opposite of the other one. No, I would prefer if I don't know. Do they have access to the slides? The slides. Yes. Okay, that's fine. So please, the only thing I'll tell you, because we are running out of time, I need to get to the end of this and then prepare for the next class. But I would advise that look at the beginning slides, and maybe in our next class, I always like to, backtrack a bit so that we can proceed with the next class. So look at the answer. My answer to that question is that please we proceeded further. Then look at the earlier slides and see the difference between the traditional or conventional programming and machine learning.
Second question, how do you think AI will impact the deaf and blind person's daily activity?
How
How
does
do
it?
you think AI will impact the deaf and blind person's daily activity?
The deaf. Okay, if we talk about the deaf, I don't know.
When can hear?
The deaf, I know. They can't hear. And then they use the blind, they use the braille, And then if you look at the kind of braille that is being designed today, you can actually use it to interact with AI. And it will give you, just like we other people that can hear. If you use the brain, you can use the brain also to interact with AI, and it will still give you the same output. For the blind, I want to throw that question to the class. How can AI impact the blind? Please, yes.
AI is more of, let's take it to robots, or it's more of sensors. It has a lot to do with sensors.
I'm just excited.
If we go to,
I hope they can hear.
Yes.
if we go to probably the robot aspect of it, it has to do a lot of sensors. So the blind can use to develop maybe gadgets that, since it has to be sensors that can help the blind move with the aid of those sensors, help them move.
I predict. I don't know if that answers your question because it's actually right. It's correct.
Because they said we have sensors that could help you navigate and environment.
You know, they have AI kids. You can produce an AI kid. It's existing. They know
There's an obstruction.
if there's an obstruction. It's like like living in an AI house. If you are blind and you are living in a house that is AI empowered,
Smart
a
house.
smart house, you don't need to see before you put on the music. You really don't need this your sight. You can be in the room
Siri.
and Siri is giving information. So you see, AI can help you. Even those that are using their sight, they still use these tools. It is even enhanced for those that need, extra help with those things. And that's why AI now makes life easier for the blind.
And I think there are some type of blindness that maybe the optic nerve is not affected. So I think now there are what's in the name, like goggles that are like artificially intelligent in that aspect. If the optic nerve is still functioning, it can aid that type of blindness.
Beautiful, you hear that? There are eyeglasses that are sensitive. They are now being created using AI technology to be able to aid people. If your blindness is just that type. I'm not a medical person, but I think I understand that. That's how we can use. So when that's why towards the end of this course, you're going to learn about the applications and look at the different application areas. That's where your own individual fields will come in. Most of if I am going to be in the team that will vet your project, I will insist that your area of specialization should be your focus. How can AI impact economics? So you can learn more, and AI can be a tool for you in that area. Do you understand? Like medical, this is the medical field now. AI is impacting health, just like what you described. That's why I chose impact. There are some of them that have not been able to make them, but some of you have played around with it. I know about the AI kit that you can use. She just talked about the programs, glasses, and so on. How there's this sensor that you can put and know your whereabouts. AI in health. I don't know if I answered the question. Any more questions? Do we still have time?
9 minutes.
Okay. Thank you very much. Do you know the deep learning?
Yes.
We have achieved my aim for today. So we have an introduction into deep learning. So we'll go deeper into neural networks in the next class. It's nice teaching.
Thank you.
Beautiful class. Thank you.
Please, before you mention it,
The attendance. Who has the attendance?
give it up and move it to the next.
Mr. Ode, Please. It's Mr. Highest system. So this one was direct. It wasn't uploaded onto the system.
It was uploaded.
Okay, so I can. Okay, maybe I just extract it. Maybe eject it, please, for me.
But you're saying new class, I mean, next class will soon start. The next class will soon start.
Oh, that's true. I forgot. I was going to say that. Wow.
It's okay. It's okay. Like, maybe you moved everywhere. No. The class is pretty calm.
Let me just try and look for water.